we are a quantum software company that is founded in Singapore, founded by a group of academics who have been studying quantum computing for many years, and we decided that it was time to join the effort to make quantum computing useful, and that's our mission. And how we are doing this is by building a compiler software that enables people without quantum knowledge, which is a lot of people, so developers out there, to build applications that can run on quantum computers and find accelerable pieces of code that can run on quantum computers from classical code. So without any quantum knowledge, they will be able to take the domain knowledge from that application and be able to construct and expedite quantum programs into quantum programs. One of the challenges from a software perspective is to be able to abstract programming a quantum computer, so assembly language essentially, and make it more abstract so that people would not have to learn quantum mechanics in order to program a quantum computer. And we think it's possible, and that's what we're trying to do, by breaking it down into little math problems or little pieces of problems, and then finding the solutions that will fit onto a quantum processor and be able to accelerate that. And coming back to a point that was raised earlier, it doesn't have to be the whole problem. It doesn't have to be a gigantic behemoth of a repository that you have to speed up, but it might just be a small piece. And I think to expand the use cases, find algorithms, is one of the big challenges of quantum computing that we need to, one of the barriers that we need to overcome. There's an algorithm for secure delegated quantum computing called the blind quantum computing that was actually co-invented by Horizon's CEO, Joe Fitzsimons, which actually allows a program to be delegated on the cloud, a quantum program, and then run on the remote server, and then return the answer in which both the program and the data that's being sent is actually unconditionally secure. And that's interestingly, and it's the quantum techniques that allow this functionality. There is no such functionality in classical computing. So in a way, if we can unlock quantum computers and have a functional ideal quantum computer, you can be able to send information and process the information completely securely. We do need, on one hand, very deep tech experts, like people who are specialists in quantum computing, who have PhDs, coming from master's programs, who can actually create algorithms and things to push the boundaries forward in this domain. But also, what we're seeing is that because quantum computers will have to interface, is essentially cloud first, because the first system that's accessible to public, the IBM Q, in 2016, it's on the cloud, and you have to access it. And also there's control systems around it, electronics for addressing microwave that control the qubits that's inside the refrigerator. So all of that industry around the quantum computing chip has to come with other types of expertise, like fabrication, in our case, software, writing software itself. We do need software developers with very good software skills. I can't really write software very well, but I have to learn. And likewise, coming from the other expertise that we do need to interface nicely and seamlessly, as you all say, right, to collaborate, but also to allow users to access the quantum system that might be sitting 10,000 miles away, in Yorktown or in the US or in Europe. And I think, I guess just drawing back to a local ecosystem, I'd like to say that even though we will benefit from more expertise in this area and more PhDs, we are not held back. I think the amount of progress we've made in advancing the hardware and software, we're counting. When I first started more than 10 years ago, we're seeing progress, maybe every 5 years, and then suddenly it's every 1 year, and now we're on a weekly basis. You pull up the publications, preprints, and you say, "Oh my goodness, that's exciting!" And it happens weekly and monthly. So I think we're not held back by that. But I think we should be able to. We would have to grow more talents in this area.
Yeah.